Hello everyone, today let's solve the problem wonderful randomized sum, right? So this was asked in the Codeforces bit around 33, right? This is fine. We can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So let's see what the question states here. 1 second, just give me a second here. Yep, just 1 second. Yeah. So here we may flip any prefix, right? So we may fix any prefix, meaning we can multiply all its element by -1, right? And then flip any suffix, right? So we may flip any prefix first, right? Meaning multiply all its elements by the -1, right? So we may flip and then we may flip any suffix, multiply all its element by -1, basically the same thing, right? So we may flip any prefix and the suffix and then suffix, prefix and then suffix. Just remember this one, the prefix and the suffix may overlap, so these two things may overlap, it doesn't matter, right? So just keep this in mind, the prefix and suffix may overlap. What we need to do, we have to find the maximum possible total sum of the sequence. Maximum, what we need to find here, maximum possible total sum, basically, right? Maximum possible total sum, basically, right? So this, I believe this is clear. What we need to find here, we need to find the maximum possible total sum of the sequence after performing these two operations. Nothing but we have to flip the prefix and then we can flip the suffix, right? So nothing but multiplying all its elements by -1, both for both, basically prefix and the suffix. So we need to find the maximum possible total sum of the sequence after performing these two operations, right? Each operation can be can use an empty segment as well, right? So this is one of the conditions. Just remember this one, each operation can use an empty segment, right? Constraints we have been given here. See, n greater than or equal to 1 and less than or equal to 10 to the power of 5, right? And also this one a, this one ai, they have represented this one, right? So this one has to be between 10 to the power of 4 and 10 to the power of 4, right? So this is fine, I believe. So this one minus 10 to the power of 4 and 10 to the power of 4, this is fine, I believe. So I hope the question part is completely clear, man. Again, let me read out this one loud. Just listen to this. We may flip any prefix, nothing but multiplied by all its elements by -1, and then flip any suffix, again same thing, multiply all its elements by -1. The prefix and the suffix may overlap, this one here, this is fine. So we have to find the maximum possible total sum of the sequence after performing these two operations, right? Each operation can use an empty segment, right? Constraints n greater than or equal to 1, less than or equal to 10 to the power of 5, and ai, or the a, between -10 to the power of 4 to this one plus 10 to the power of 4. So this is fine, I believe. So this is the question, basically, right? So let's move on with the input output part one. So see here, we have 3 we have 3 here, and this one -1, -2, -3, the output that we need to get here is 6. This is fine, I believe, right? So this is the question, basically, right? Same goes with the example 2, example 3, right? So I hope the question part is clear. Next, let's do one thing. Let's quickly discuss the this one, what do we call, approach, then followed by the complexities, and then let's write the code. Initially, let's discuss the approach first. So here I have considered the same first example that they have given in the question one. So 3 -1 -2 3, this one is fine, and the output that we need to get here is 6. This is also fine, I believe, right? So one more thing, so we'll be making use of the dynamic programming to solve this particular problem. Just keep this in mind. Again, we will be making use of the DP, or the dynamic programming, to solve this particular problem, right? So let's move on with the step-by-step explanation. So let's discuss the DP idea first, right? So we'll be going with the DP along with the prefix of the suffix sums, right? So accordingly with the question, we know, so we have to go with the prefix and the suffix, nothing but multiplying with the -1, right? So all the elements with the -1. First, let's go with the prefix part, nothing but pre-compute the prefix sums, right? So this one will be making use of the variable st, and also suffix sums will be making use of the sn, right? So for the prefix sums we'll be making use of the st, and for the suffix sum we'll be making use of sm. So this one, sum of a to 0 minus I, so this one sum of a to n minus 1, the last element, right? So the suffix sum, for the suffix sum, this is fine. So first what we'll do, we'll be considering this one, dp of I is equivalent to the this one, best total contribution from the subarray, nothing but I to n minus 1, the last element, right? So this one is fine, right? If the second operation is allowed to begin at this one position greater than or equal to I, this one we will get to know when we write the this one code. Let's move on with the further steps. Basically, let's move on with the recurrence, right? So at I, either we have to start the suffix flip at I, right? So at I, again, either start the suffix flip at I, nothing but the contribution this one minus negative suffix of I, or don't start it at I, right? So we can either start this one suffix flip at I, or don't start it, right, at I, and keep a of I and let it start later, either we can start the suffix flip at I, or don't start this one at I and keep a of I and let it start later, right? So nothing but a of I plus dp of I plus 1, the next element, a of I plus dp of I plus 1. So dp of I equals, we'll be going with this one, this is kind of formula, basically this one will be going with, basically, right? So dp of I equals max of hyphen suffix of I comma a of I plus dp of I plus 1. So this one will be making use of the code, just try to remember this one, this is important, right? So base dp of n minus 1 equals absolute of a, this one, a of n minus 1, this is fine. So finally what we'll do, we'll consider whether we also flipped from some prefix, right? So either no prefix flip, this one flip, or the flip prefix 0 to I, and we'll be combining with the best suffix on I plus 1 to this one, hyphen this one is nothing but the prefix of I plus dp of I plus 1. We'll be considering maximum overall I, let's try to implement the same thing for the example one. You will get to know this one easily rather than the theory part, lot of theory part, right? So let's apply the same thing to the first example. So we have been given 3, nothing but the number of elements. So this one is minus 1, minus 2, minus 3 we have, right? So prefix will be going with the this one, what do we call prefix, this one st is nothing but the prefix, sf is nothing but the suffix, right? So prefix, this will be quite obviously minus 1, minus 3 and the minus 6. So this one will be minus 6, minus 5 and minus 3. The second step is we'll be computing dp from the right, meaning reverse iterations, right? So this one will be, first we'll be going with a dp of 2, then we'll be going with a dp of 1. So this one will be absolute of minus 3, it's nothing but we are making use of math.absolute, right? So this one in the code will be going with a math.abs. So this one will be we'll get this one in the whole number, nothing but 3 here. dp of 1 is max of suffix, this one, right, minus sf, whatever I have given. This one is nothing but the suffix of this one. This will lead to the suffix of 1, basically this will lead to 5. So a of 1 plus dp of 2 will be going with nothing but here minus 2 plus 3. Minus 2 plus 3 will lead to 1, right? Minus 3 plus 1, minus 2 plus 3 will lead to 1, basically. So overall answer, so we are considering we have to consider max, right? So maximum will be 5, maximum of 5 comma 1 will be quite obviously 5 will be considering here. In this case we have got 5, right? So this is fine. dp of 2 we got 3 and dp of 1 we got 5, right? So see here this part, just give me a second, 1 second, what happened to this one, 1 second. Yeah, this one, dp of 2 is 3 and dp of 1 is 5, right? So this is fine, just remember this one, right? So this is fine. So dp, we haven't calculated the dp of 0. So we have 3 elements, right? Reverse iteration we are doing. So we have to go with the dp of 2, 1 and finally we have to go with the 0, because we have elements, 3 elements, minus 1, minus 2 and minus 3, this one, right? So this is fine, I believe. So dp of 0 is nothing but the max of minus suffix, this one of 0, nothing but this is equivalent to the 6. So we'll be going with the a of 0 plus dp of 1. So a of 0 value is minus 1 plus dp of 1 is nothing but, we have already got the dp of 1 value, nothing but 5, right? So dp of 2 is nothing but 3, dp of 1 is nothing but 5, we know this one, right? So dp of 1, 5 will be giving here, minus 1 plus 5 will lead to this one, what is called 6 comma max of 6 comma 4 basically. Minus 1 plus 5 will lead to 4, right? Max of 6 comma 4 will consider 6 basically here. This one will be going with a 6. Basically we got 3, 5 and 6 I believe, right? Yep. 3, 5 and 6. Right, so 3 for the dp of 2 basically, this one dp of 1 and this one dp of 0, 6 for the dp of 0, 5 for the dp of 1. So answer will be considering max of dp of 0 is nothing but which is equal dp of 0 is nothing but equivalent to 6. We know here this one, right? And this one is prefix st of 0 plus dp of 1. So this one prefix of 0 is nothing but the 1, and dp of 1 we got here this one 5 basically. So 1 plus 5 will lead to 6, right? Again we'll be going with a this one prefix of 1 plus dp of 2, nothing but here this one will be 3, dp of 2 we got 3 here again, right? So this one will be 3 plus 3 which is equivalent to the 6, right? So which is equivalent to the 6 basically, right? So the final output that we got here is this one 3 plus 3, this one will lead to 6 basically. The output that we got here is 6, which is equivalent to the output this one that they have mentioned for the this one mentioned for the example one within the question. So our approach works absolutely correct. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? I believe, yeah, let's quickly discuss the complexities part, right? So what will be the time complexity here? The time complexity would lead to big O of n. So why it is big O of n? Because we will be building, or we accordingly with the approach, so we'll be building prefix or the suffix arrays, right? And also we have to fill the dp and the final loop, right? Dp and the final loop basically, where each of it are linear basically in simple terms. So overall time complexity would lead to big O of n. So what would be the space complexity here? The space complexity would lead to big O of n because we will be going with 3 integer, this one 3 integer arrays of length n, this one of length n, nothing but sf, st and dp. So sf and st we have considered. St is nothing but the prefix, sf is nothing but the suffix, dp is nothing but the dp array, right? So plus the input array a also will be considering. So overall space complexity would lead to big O of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big O of n and big O of n respectively. So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So we'll be making use of the input output, fast input output, right? So I'll just go with import here java.io. Let's start. Let me import the input output package. So next let's go with a class. I just go with a class main as usual, so I can just give any class name, right? So that's relevant to the question. So I'll just go with the main method inside the class. Remove this one and let me include throws this one exception. So this is fine. So within the this one main method, first thing is let's go with the input output. I'll just go with the buffered reader br equals new buffered reader. This is fine. New input stream reader. So this is also fine. So this one will be system.in. So this is fine. Next let's go with the print writer. Print writer. So this one will be output equals new print writer. So this one will be system dot out. This is also fine. Now let's read the number of elements n. So this one will be int n equals integer dot %. So this is fine. This one will be buffered reader dot read line. This is also fine. So next step is we have to go with the array to store the input values, right? As I've said, we'll be going with the input array a basically, right? Array a. So I'll just go with a equals, let's initialize this one to the new int of n basically. This is fine. We have to read the line of n integers and split by space, right? So I'll just go with the string here. This is related to the input output part. So this one will be buffered reader dot, as we have considered, read line, and also I said we'll be making use of the split as well. So this is fine. Next we have to parse each string to the int, and we have to fill the array a as well, right? So for that, let's move on with the iteration part. So this one will be int I equals 0, I less than n. Let me increment I here. So this is fine. So this one will be a of I. We have to assign this one to the integer dot parseInt. So this one has to be s of I. This is fine, I believe. Right, next let's go with the we have to initialize the sf to the suffix sums and st to the prefix sums, and also we need dp, as I've said, right? So we have to go with sf, st and dp. We have discussed this one already, right? So we have considered the same thing in the approach as well, right? So I'll just go with the variable sf. So let me assign or initialize this one to the new int of, let me pass n here. Also st, nothing but the prefix sums. So this one will be new int of n again. So next let me go with dp equals new int of n. This is also fine. So this one will be suffix of n minus 1. Let me assign this one to a of this one, n minus 1. So we have initialized the last suffix sum as the last element, right? So this is fine. Now let's move on with the for loop here. So this is fine. Int, so this one I equals n minus 2, I greater than or equal to 0. So let me decrement the I. So this is fine. Suffix I, this one equals a of I plus suffix of this one, suffix sum of I plus 1. So we are just building the suffix sums here, nothing but s of I equals a of I plus suffix s of I plus 1 in simple terms, right? So this is fine. We are done with this part, right? So the next part would be we have to initialize the first prefix sum as the first element, nothing but prefix sum st of 0, first prefix sum, this one, right? First prefix sum as first element, nothing but a of 0. This is fine, I believe. The next step would be, so we have to build the prefix sum as well, right? Build the prefix sum in the sense, so st of I is nothing but a of I plus st of I minus 1, the previous element, right? Prefix sum we are going with, right? So we have to go with st of I minus 1. So let me write the for loop again. Let me type this one instead of copy pasting. So this is fine. For int I equals 1, so this one is I less than n, I plus plus. So this is fine. We are going with the prefix sum, alright? Of I equals a of I plus st of I minus 1, because I minus 1, because we are going with the prefix sum. We are building the prefix sums basically, right? So this is fine. Now we have initialized the first prefix sum as first element, and we have built the prefix sum. Before that, we have initialized the last suffix sum as last element, and we have built the suffix sum. So we in directly or in the simple terms, if I want to say, we have successfully built the suffix sums and the prefix sums. Now the next step is, after building the prefix and the suffix sum, we have to go with the dp as per the approach, right? So now let's go with the base case first. Base case is, for the last element, best we can do is max of a minus 1 comma this one a of n minus 1, that is equivalent to the absolute of a of n minus 1, right? So then we'll be going with the iteration, or we'll be filling the dp from right to left. Finally we'll be going with the dp of I. See here, I'll just go with dp of n minus 1. This one equals math dot absolute. This is fine. Now let's do one thing. I'll just go with math dot absolute. So this one is a of n minus 1. So this one is fine. For int n equals to I greater than or equal to 0, I minus minus. So this is fine, man. Now let's go with iterated value of the dp. Nothing but we are filling the dp from right to left, right? So nothing but dp of I equals, so if you remember the approach, so we have went with math dot max of this one minus suffix of hyphen suffix of this one I comma a of I plus what we went with dp of I plus 1, right? Suffix dp of I plus 1, right? For the prefix it will be I minus 1, right? So this is fine, man. Now let's do one thing. Now let's go with the, or let's start with the case no prefix flip and best suffix placement, in the sense and answer this is equal to dp of 0. This is fine. Next let's move on with the for loop here. This one will be int I equals 0, I less than n minus 1. So let me increment the I here. So this is fine, man. Now let's assign the answer to mat.max. So this time prefix sum, right? So this one has to be st instead of the suffix st of I. This is fine. Plus dp of we have to consider every possible prefix flip that is ending at the I basically. So this time we are considering the prefix, but we'll be going with the dp of I plus 1, the next element, not the I minus 1, right? So don't get confused here. So this is fine. So basically if we flip prefix of 0 to I, their total becomes this one, a hyphen st of I, right? So for the remainder I plus 1 to n minus 1, we can either choose the best suffix placement dp of I plus 1, and then we can just choose the best suffix placement, nothing but the dp of I plus 1, then combine them and we can just take the maximum over I, right? So that's what we can do. So finally after doing this, what shall we do? We are left with only this one, two steps. One thing is we have to print the result, nothing but we have made use of the print writer, right? So the print writer variable is out. I'll just go with the println. So let me pass answer. This is fine. And finally let's flush the output. This one will be out dot flush. Yep, we have successfully flushed the output, right? So this is fine. We are done with this part, man. Yep, right? So we are done with the coding part. So this is it for the coding, right? So let's check, before checking the code with different inputs or the examples, let's do one thing. Let's check the, let me copy paste the signature starter template. Just come here, let me paste it over here. So this is fine, man. I'll just come here, let me copy this one. The output that we need to get here is 6. This is what we discussed, right? This is fine. What we have here, variable n is already defined in the method main string. So line number 39. Oh, this one. Oh, where is line number 39? So this one basically what we are doing here, in 1 second, a suffix we have went with where is this one? If I this one, so this is fine. So here what I have given for this one has to be int I equals n minus 2. This now there, now the error is completely gone. We are getting the correct output, right? So that was the main problem basically. Let me copy this one. The output that we need to get here is 11. Let's check the same here. Yep. Now we are getting the output 11. So that was the main problem basically. So finally let me go with the third input here. The output that we need to get here is 18. Let's check the same here. So we are getting the correct output, which is 18 basically, right? Now let's do one thing. Let me copy the entire code here along with the starter template. So let me click on the submit code. Let's wait for some time. Let me stop this one and reload, man. Why this is taking so much of time? So yeah, I'll just come here. We have to select actually what problem is it? C, right? Yeah. So why this is not showing the pointer at all? Let me reload this one again. There is some problem with this page actually today. Let's wait for some time, man. So let me do one thing. This is not taking at all actually. This is not let me consider C. Still it is not showing the pointer at all. I cannot do anything here. So let me do one thing. Just come to downloads here. Let me create new file here. Just give me a second here. Text document. So I'll just name this one text document itself. No worries. So I'll just come to this one compiler. So let me copy this code entirely. Let me open this one and let me paste it over here. Right, so this is fine, I believe. Now let me do one thing. I'll just come here to this one. Yep. Let me choose the file. So this is fine. Let me select this one from the downloads. So let me hit the submit button. So I hope this works. Let's see. I don't know why it is not allowing at all to paste the code actually. I don't know what's the problem. See, the loading also it is taking long time basically. I don't know why. So this is still taking time under this one. In the submissions it is showing accepted one. See here, in the submissions it is showing accepted, means whatever the code that we have written works absolutely correct, right? So yeah, whatever the code that we have written works absolutely correct. So we have made use of the pure DP here along with the prefix or the suffix sums, right? So ST stands for the prefix sum and SF stands for the suffix sum, right? So this is it for this particular problem, right? So the verdict that we got here is accepted basically. We have some problem here. I don't know why this is taking loading for the long time. This is fine. Now we have got the verdict accepted, meaning our code, whatever the code that we have written, works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.